managing almost a vast portfolio of projects across the world. But for now, maybe let's focus on Scheldebouw. We have 2 locations. One in Middelburg, where we have a large factory and office. And in Heerlen, we have, I think, almost as equally large engineering's office. Together, we accommodate design and engineering, project management, manufacturing, and even to installation of our own facade. But I think maybe the company presentation speaks for its own. So please just sit back, enjoy a couple of minutes of the company presentation.
City skylines, shaped by iconic statues of modern architecture. Glancing up at these shiny facades often feels magical. But it is not magic that creates these monuments of the future. At Scheldebouw, we know it takes expertise, experience, and devotion to create skyline-changing buildings. Creating something outstanding requires new ideas and tailor-made concepts that make them real. That's why we don't choose paved roads. We think in possibilities, we breathe challenge, and we reshape technology to create new visions. Our engineers design solutions that transform ideas into remarkable curtain walls that protect building inhabitants from the elements outside. We have an uncompromising focus on excellence, and we test our designs in ways that exceed your expectations. At the core of our manufacturing facility lies customization and a commitment to perfection. By tracking everything we do, we keep a tight grip on even the smallest detail. It's this kind of commitment to excellence that is reflected in the exceptional quality of our panels. In fact, excellence is of such importance to us that our assembly area maintains clean room standards. Driven by perfection, we leave nothing to chance. Our daily quality control makes sure every component complies with our quality standards. Our commitment extends far beyond our facility floors. Our large warehouse allows for meticulous planning on even the largest projects. On-site excellence is just as important to us. Our unitized panel installation minimizes time on site while guaranteeing thorough and precise installation. You might be wondering why we are so devoted to excellence. If the skyline of the future was your canvas, wouldn't you be?
All right. So what we actually do and try is translating ideas of world's greatest architect into reality. But how do we achieve this? How does our process, strategy look like? And I begin by explaining it with an example, a project. This project I'm showing right here is called The Shard. It is located in the United Kingdom, specifically in London. The Shard's architect is famous architect, Italian architect Renzo Piano. And when asked to build a project of this quantity, it came to us. This project landed on the tender department where I'm from. And at that part, we first start with trying to make his concept idea feasible. We're making concept designs. And with those concept designs, we are going to make preliminary building physics calculations. Backed with those concepts, we try to make a best pricing and also paired with a great plan of approach. We hand it over to our client, and hopefully we are granted with the project. And this we were. It goes directly to the design and engineering department. And at the design and engineering department, all of our engineers are going to detail the facade, going through every small detail. No detail will be left untouched. And when that's all defined, we're going to make a visual mock-up. And that's what you see in the middle of the presentation. Above you see a sketch, and at the bottom you see a one-on-one scale of a visual mock-up. A visual mock-up is to give the architect and its team an idea of what he's actually buying. We will make a section of the building to what he and we agree on, and then he can inspect it. If the inspection is sufficient enough for the architect and its team, and also the client, of course, then we go to our testing phase. At the testing phase, we make a real element, and we're going to start it with kind of like simulating modern nature, but also in a controlled environment in our factory. And when the element, well, is all to its needs, it goes to the production. That production goes quite quickly, but it's all streamlined and also tailor-made to that specific project. Then it goes to storage. Sometimes it goes to storage actually, and sometimes it just goes directly to site. It depends on the form of contract and it depends on the space on site. But even then, we also go to the extent of installing our own elements, unitized facades at site. But I talked about unitized facades, but I'm not sure if we are familiar with unitized facades. So maybe let's explain it. And I'm going to explain it by means of one of our most recent Dutch projects. It's already finished. It's in Amsterdam near the Central Station. For us it's called booking.com. I don't know how the client now calls it, but the client of this project actually was booking.com himself. He financed it, he coordinated it, and then he eventually sold it to somebody else to rent it back. So it's a quite remarkable construction, but it's something that works. But nevertheless, he asked us to build a facade. And so first thing to make clear is that our facades are tailor-made. You won't find any facade in the world made by us that's similar to this one. First, we start with designing a structural set. A structural set is made from aluminum, mostly. It can be made from wood, but we now focus on aluminum. It's made from aluminum mullions and transoms, and those are the backbone of your framework. Around the framework, around the perimeter of the frame, we apply our state-of-the-art, in-house designed gasket system. That gasket system guarantees a very good, great air permeability and watertightness, specifically to the project. And from that on, you can just fill in your element with anything what you would like. Would you like some aluminum presswork, or some glass reinforced concrete, or some wooden infills? Almost every material is possible. But for this project, the architect wanted a lot of glass. But not just glass like flat in plane, but he wanted glass to pop forward like an architectural fin or feature. So due to our in-house design, our engineering expertise, we're able to generate it for him on a customizable way and also on an efficient way to guarantee the best performance, but also to guarantee a great quality control. But maybe let's go a bit more technical, just to see what I'm talking about. How would it look like? And I like to explain this first by means of a horizontal section. I'm going to turn myself to the screen to point it out. So you got to imagine, I totally understand if you don't totally get it, but I'm trying to explain it. So the yellow part, that is your aluminum frame, that's your aluminum structure, that are extrusions custom built to the project. We sometimes reuse extrusions to make aftermarket parts or just replace things because something is broken. But every extrusion you see here marked in yellow is custom made. Then you have in black, that is your gasket system. You have two types of gasket systems. One gasket system to actually close your infill. In this case, it's the blue part, your glass. But we also have in the middle 3 layers of defense. First and second layer are for water penetration, and the last one is like your interlock gasket, and that's for your vapor tightness. And also marked in red, you see the bracket. But I will get to that in next slide. So for this, it's actually the same. The yellow is your aluminum, but in this case, it's not your mullion, it's your transoms. Transoms are horizontal, mullions are vertical. And black, your gasket system. In blue, your glass. But in red, your bracket. And also what you see here is that your bracket is positioned on top of the concrete slab. Sometimes it's wood, sometimes it's steel, it depends. But most times it's concrete. Those brackets are pre-designed before the installation of a unitized facade comes. Because unitized facade is all prefabricated. We make it in fast bulk and we can install quite quickly. Because those brackets are pre-installed by a different team. They lay out the bracket layout, they go to determining if the dimensioning of the bracket and the position is correct. So when the element arrives, it's as easy as almost you see at top. Just slide it in place. The brackets are preset. Your facade is up to standards, up to dimensioning. You have calculated your tolerances and you can really just lower it in place. And you don't need like any extra sealing or anything else to apply to make it like weather tight. But due to our gasket system, it's almost like Lego. It's click and play and you're closed. That's why a facade element can be installed, a unitized facade element can be installed in a matter of minutes. So a unitized facade also comes with a couple benefits. Some high installation speed due to our bracket system, preset, and our gasket systems. But besides our bracket system, our facades are already produced in factory. And that also comes with high safety standards due to most of our products are prefabricated in a controlled environment. Due to our controlled environment, we can ensure high quality assurance. And besides that, due to our large engineering capabilities, we're able to generate complex shapes and implement them in smart facade solutions due to our customizability of our own facade, of our own product. Besides that, we have vast knowledge also to accommodate large building movements and also can enhance your facade to perform better on acoustic performance. So now that we have kind of the same level of general understanding of a unitized facade, what about the impact of smart, sustainable engineering in the facade industry? And I'm going to talk about 2 topics here. Embodied carbon versus operational carbon. And also I'm going to talk about how you can influence the other to gain a better outcome. And let's start with embodied carbon. I think you're all familiar with it, but I will do a short resume. So embodied carbon are the total greenhouse gas emissions generated during the life cycle of a product. And for this case, I mean a unitized facade. Addressing embodied carbon requires a holistic approach for a unitized facade. That encompasses the entire life cycle of a facade. We as industry professionals constantly try to increasingly adopt new practices such as life cycle assessments, but also to quantify and reduce embodied carbon along with new construction techniques or innovative materials. But there are certain areas in your facade which you can make a larger impact. Most of our facades are constructed from, as I mentioned earlier, aluminum and glass. It's also possible to make it from wood, GRC. I think you named the material and we've already done it once. But to influence the material, we have to focus on the biggest bulk of your material. I'm going to explain that by means of a project. Because at this project, We were the first industry professionals to get an environmental product declaration on a unitized facade. It has been done previously with smaller materials, like raw materials, but not in a finished product where you assemble products into one. An EPD is a document which transparently describes the carbon performance of its lifetime. It's something like a carbon performance passport, actually. So this project I'm talking about is called N2 Nova Evolved. There we defined an honest waistline to no greenwashing and calculated in a whole picture. And that's what you see displayed here back me on this pie chart. And we specifically have done this for one panel, FT01A. And what you see here on this pie chart is that most of your materials are in the glass and in the framing. And overall related, you have materials of 271 kilograms CO2 equivalent per square meter of facade. So if you want to influence that, that's where you're going to focus. And of course, we can go to low carbon variants, that's obvious. But before that do, let's maybe optimize your design, try something different, or what's the impact on it? Because in the beginning when we were designing the project, we discovered that we weren't meeting the sustainability goals. The architect wanted variant 2, large fin, providing shade. But you see directly that those carbon are much higher than variant 1. We offered it to the client to propose it like, all right, if you're going to omit your fin, but then you have no shading, we can lower your carbon by like a lot. I didn't put numbers here, so I can't call it out. But it is quite an impact because we are talking about 20,000 square meters of facade on a building. Eventually, we tried to get the best option. So then we switched to maybe just, for now, try low carbon variants, so low carbon aluminum for this case. And then you see also a decrease of embodied carbon. But what this doesn't display is maybe the consequences or the small catch to taking low carbon variants. Because low carbon variants aren't in vast quantities. It's all about the availability of aluminum. Because if you see a kilo of aluminum extruded by an extruder, which uses green energy, compared to one who is not using it, you don't see a difference. It's the same. But it's all in the way the aluminum has been produced by clean energy, say like a water power plant or a wind power plant, something like that. Most of these fabricators have their own power plant to supply the factory because it goes in quite vast quantities, large amounts of energy. And this is the same for low carbon glass. That doesn't sound hard, right? But there's the problem, because there isn't enough of the product on the market. You can want it, you can ask it. It's always, most of the time it's also, you get more subsidies, most of it in England, but sometimes you get more subsidies for using low carbon variants. But it's not for hand on the market. So maybe let's just stop there about embodied carbon and go to the other topic I was talking about, operational carbon. So operational carbon has been on reducing your operational carbon during the use of a product, and also for this case, focus on the facade. But I think for you guys, a facade is like a static piece. When it has been installed, it doesn't do anything, it doesn't contribute to the operation of it, right? But no. We have a special product, it's called a CCF facade, closed cavity facade, which contributes exactly in this piece of operational carbon. That facade has a better thermal insulation, solar shading, lower G values, and can also be integrating solar panels and photovoltaic photovoltaics, solar panels, right? And this has been done just by adding more material. So that's worse on your embodied carbon. But I will make the link to that in a couple of slides. So what is a closed cavity facade? And if I would try to explain it to you guys, it's like a large triple glazed window, but then with a cavity inside it. I'm going to break it down for you. We've got the outer pane, the glass, and the outer pane, the double glass. And inside we have a cavity. It's dry air supplied and managed by a Venetian blind. And that Venetian blind can be used to benefit the operational carbon. Because if we compare it to a single skin facade, in my previous example, a double skin facade gives a lower U value for better thermal performance, and that also contributes to the lowering the thermal cost of the overall building. Your blinds in the cavity help to generate more daylight because you can omit solar coatings. Oh, I'm sorry. But omitting solar coatings, you can manage the heat transfer entrance by using your blinds. Your blinds can keep you cool in summer, keeping the heat out, but your blinds can also keep you warm in winter by keeping the heat in. Besides that, because the blinds are in a closed cavity, it is controlled in a protected environment, and that's beneficial to the maintenance. You don't need cleaning, less repair. And it also extends the lifetime of your DGU inside. Normal lifetime expectancy of a DGU is like 20, 30 years, and then it's really up for replacement. And besides all that, a CCF facade also vastly increases your acoustic performance. So a CCF facade, a closed cavity facade, can assist into achieving the high sustainability ratings, like BREEAM, LEED, and even the passive house. And we've done this before on our most recent CCF project. It's called 8 Bishopgate. And you see it here by the headlines, but we didn't just make those headlines by making a nice design, because actually the whole facade is just made of a glass. And we did it by working together with the client. We optimized the facade building outline, showing that adding more material to your product isn't necessarily that bad. Because at the back here you see the chart and the pictures above the facade. You see a deviation of 3-meter facades and 1.5-meter facades. And you don't necessarily add more mass, more material to your facade if you go wider. It's more evenly distributed over a larger square meter. So by adopting this, by optimizing this, we can lower your embodied carbon. And combine this with your operational carbon. Because at your operational carbon, a single skin facade is static. A double skin facade can be dynamic due to the blind. But because you're adding more material, you have a longer return on investment. But we have calculated and experienced this before, that your return on investment on adding more material, having a higher embodied carbon, will be in 10 to 15 years. Well, and I'm almost coming to the end. I hope it was a bit clear. So maybe just do a short summary for you all to remember. So by optimizing your design, we can build with lower embodied carbon. Due to the optimized design and the choices of a closed cavity facade, you can also lower your operational carbon by much, much more. And that's not only specifically for your facade, it's also for your building. Besides that, a double skin facade leaves space for more daylight, and this results in a more usable office space. By implementing blinds, we can dynamically manage the performance of the facade all day long with every season. And aside from all the technical stuff, it's also quite cool. It's a technical masterpiece in the facade industry. So after all these optimizations, design choices, you can influence to lower your overall CO2 reduction, but not only for the facade, but also for the whole building CO2. And with that, I'd like to thank you all for listening, and hopefully you all enjoyed it. I hope you're all looking in the facade in a different way. And if there are any questions left, or need my contact details for something else, please scan. And if you have questions, please do ask. Thank you very much.
Are there no questions? If there aren't any questions, I want to thank you all for coming. And you can scan your campus card upstairs to receive your My Future Point.